Welcome. This is a brief introduction to the realex application. Realex is the improved user interface for the Atlas software, and we recommend that you use it instead of the native Atlas application, which is called Atlas, unless you have a particular need to use Atlas directly. This video assumes that you've already installed the realex software and have it running. If you need help doing that, see the Getting Started with Atlas video. So here I've assumed that you've already installed the software and I have the files that I need in this directory realex scripts. So let's take a look at what is in this directory. There's a number of files, starting off with this file k.rx. So any file ending in the extension .rx is a file of supplementary commands for use by realex, all the way down to filegroup.rx. There are also some text files here, readme, the examples, functions.help. There's a realex.help file, and then a couple of files with show all in the title. I suggest you take a look at these. These have various kinds of helpful information about the realex software. I'll take a look at a couple of these. So the file realex help is a fairly extensive introduction to the realex software. You might want to take a look at it. It starts off with a brief introduction to the software and then some details on how it runs. A lot of this I'll be doing examples of these things in this video, but for more explanation, see this file. Another file that you might want to take a quick look at is the file readme.rx scripts. This has a list of the different rx scripts files and a brief description of what's in them. And down here at the bottom is a little bit of information about how you actually load these files, which is important. And I recommend that you start off any session using realex by loading this file my, which loads all of the other files, and also you can put your own definitions in it. It's also worth taking a quick look at this file called show all. This is the output of the show all command in realex, and the output is quite long. And up here it starts with some very basic definitions. So for example, plus here, and this notation indicates that plus is an operation which takes a pair of integers to another integer. And here's some other examples a little bit further down. Let's see, for example, hat is the transpose which takes a matrix to a matrix. And then after the sort of notation at the top, there are a bunch of commands in alphabetical order which the software knows about. These are the built-in commands that are part of the realex software, and all the way down through these print commands. Okay, so now let's run the software itself, and here we'll check the version that we're running here is 0.81. And let's start off with a very basic. Let's just do a mathematical operation. 3 squared is equal to 9. And let's set a variable. The way you do that is you say set x is equal to 3, and the value of, if you just type x, you'll get the value of x, which is 3. As another example, let's set a vector, and the vector notation is square brackets 1, 2, 3, and this vector is, if I want to know what it is, I give the command what type, and it tells me it's this means it's an array of integers, or a list of integers. Okay. Now, the way you extract an element from a list is by the brackets 2, and numbering starts at 0, so v bracket 2 is equal to 3. All right, those are just a couple of very basic operations. Now, what I'm going to do is I want to load all of these extra supplementary commands which are available in the rx files. So I'm indicating that here. And what I've written on the command line here is enclosed in braces, and that's a comment. So these things that I'm typing here are just for you to see. They're not actually going to do anything. And to actually execute this command, I just say less than my. And what that does is it reads in the file my.rx, which iteratively loads a bunch of other files, and you'll see there's a whole long list of added definitions that it now has loaded into it. And so now there are a bunch of things that you can do. For example, you can define a group by saying set G is equal to SL2R. And let's ask what type this is. It's a real form. That's the data type of a real group. And its dimension is 3, and its rank is 1. Now, I'd like to check the underlying root datum, or equivalently the underlying complex group of this group is simply connected, and that's true. That is not to say that SL2R is simply connected. I'll come back to that another time. And let's construct the root datum of this group by calling root datum. So now the software, the software knows the underlying root datum of G. And here it says it's simply connected. Let's look at a slightly bigger example. Now let's set G is equal to SP4R. And let's look at the positive roots of this group. And these are the columns of this matrix. They're 1, -1, 0, 2, 1, 1, and 2, 0. And you see that the coordinates are quite nice. This is the human readable coordinates that most people are used to. And it also knows about the co-roots. The simple co-roots are 1, -1, and 0, 1. And row of G is 2, 1, and row check of G is 3/2, 1/2. So you can see this vector here is a rational vector. It's indicated with this over 2 at the end. Okay, so let's do a little bit of elementary representation theory. For that, let's go back to SL2R, and let's set P to be trivial of G, and P here it says is a parameter. Params is the parameter type. And I've written it out here. It's this triple x, lambda, and nu. This is the parameter in the Atlas world of the trivial representation of SL2R, or equivalently the associated standard module. So one thing we can do is we can take the associated, first let's check the infinitesimal character is 1. Well, let's see, what are the coordinates? Well, let's see, row of G is 1. So this is row, and you can actually do this equality test and see it's true. Infinitesimal character is equal to row. And now what I want to do is I want to set J to be J of P. And what J is it stands for the irreducible representation with this associated parameter, and I is the associated standard module. And there's this command mprint, which gives nice information, information about representations in a nice format. Mprint the composition series of I says that the standard module we're talking about here, which is a principal series, in the Grothendieck group is the sum of 3 irreducible representations, J0, J1, and J2, listed here in that order. And the first 2 are discrete series, and the last one is the trivial representation itself. This is the decomposition of the spherical principal series of SL2 with infinitesimal character rho. On the other hand, I can write the character formula of J. This is the inverse operation in the setting of Kazhdan-Lustig-Vogen theory. This says that the trivial representation is a virtual character is written as this full principal series minus the sum of the 2 discrete series in the Grothendieck group. Okay, hopefully that's enough information to get you started using the realex software.